So this problem comes from lesson 2.4 in our book. And the problem says write the quotient in standard form. So here we have a quotient. There's a division here. And take a look in 2.4 at example 4, writing a quotient in standard form. So when you are asked to write a quotient in standard form, you need to multiply the numerator and denominator by the complex conjugate of the denominator. And so when I'm multiplying by what's called the complex conjugate, I am multiplying by on this case, it would be negative I over negative I. I'm multiplying in essence by 1. Because if I look at what I wrote in red here, just this portion, that's equivalent to 1. So I'm not changing anything, but I'm multiplying by the complex conjugate so that I can change this to standard form. And so typically, the complex conjugate, if you have a plus bi, which is complex number, you have the number plus the complex part, its conjugate is a minus bi. Here, we don't have the standard complex number in the denominator. If we did, it would just, you would have a 0 in this place. So 0 plus I, and it would be 0 minus I, 0 minus I. So we don't even have to write the 0 portion. It's just negative I. And so what I'm going to do now is I'm going to multiply across the top to obtain negative 7i plus 3i squared. So I'm distributing this negative I to both of these terms. And then on the bottom, I'll have negative I squared. So wherever I have I squared is equal to negative 1. So I can replace the I squared with negative 1. So let's do that. Negative 7i plus 3i squared over negative I squared. And like I said, I'm going to replace the I squareds with negative 1. And that's our definition of a complex number. So here on the top, I'll get negative 7i minus 3. And on the bottom, the opposite of negative 1 is 1. So now I've wrote this in standard form, negative 7i minus 3.